Hello guys and welcome back. So now we want to add some details, some extra details to the sim so that it doesn't look very uniform in the smoke solver. So what I'm going to do is I'm going to take the velocity and use a volume valve to add details to it. But first, I don't know how it looks like. I don't know what kind of details we have. And I'm going to show you a way to visualize the force in SOPs. I'm going to use a grid. I'm going to align it somewhere so that it fits the sim, like that. Okay, I'm going to scale it up 20 by 20. Let's Control Shift this. Okay, cool. And I'm going to scatter a lot of points on this grid. Let's hide this. 10,000. I'm going to use a node called volume trail. Required points to trail, and the second one is the volume, and the velocity field is called vel. And now it's showing you the force using trails, using vectors. Okay, we can change the scale, and this is just a preview. So we want to add some cool details to this guy. Let's create a volume valve. And like we do with the attributes, we use bind node to import them and bind export to change them. When it comes to fields, we cannot, when we use a bind export with a new name, it will not add a new field here. We can only process what's already existing. So to access the velocity field, we're going to use a bind node and change this to vector, call this vel to match the name. It has to match the name. And then I'm going to create a noise. I'm going to use a current noise that generates interesting swirly patterns. I'm going to add this to the velocity. And now to change this value, we need to bind export it again. And to be clear, this does not add new fields like in VOPs, in point VOPs. It only processes the existing data. Okay, so let's continue. Let's increase the value here, the amplitude, and there we go. Now we're adding some interesting distortions to the force. Cool. Maybe something like this. Increase the frequency, increase the roughness, and we can also take the velocity. Right now it's shooting this way, the original velocity. If we do a cross product of that, we can get some interesting directions. So let's do a cross product of the velocity with an up vector and just plug it in. You see now we're getting a swirly rotation along this axis. Let's try with a Z information. It's going this way. Okay. What if we take the point position of the voxels? So this point here has a voxel, and the point position is going this way. If the point is in space here, if the point is in space, it's going to create a vector like this. So let's see what we get from this. Cool. So we get a very, very different and interesting vector. And this is very dynamic because it changes every frame, and that's a feature we would like to see. So I'm going to simply add this force here. I'm going to multiply it by a constant, maybe reduce, add only 50%, and let's bind export that. And maybe let's add 2 of these. Let's set one to be small and one to have large details, and lower this to 3. Okay. And we can also change the plane to see at different locations, but we cannot view it all at the same time. Cool. So now we have created some velocity, and I'm gonna copy that temperature thing that we did because I think it could work. I'm not sure. Yeah, something like that. And we're gonna just add this in here. connect the blast to this, and let's add a merge node. And again, the temperature, we don't have to display it. We can just use that to add interesting motion to our sim. Let's set this back to 100. Set this to 3 so that we get an extreme behavior. And I don't want to view the temperature because it can get confusing and it gives a completely different idea about the effects. And in this case, I just want dust. So I think the velocity is very strong, so let's set it to 1. And I want to increase the overall scale of these guys. So multiply all of them by 2. And the most important thing, which we didn't talk about, is being able to emit from a fast moving object, or if you wanted to create this kind of sim, it's going to be very, very tricky to do that in Houdini. I mean, you can find your own workflow for this, but this is the approach that I use, and it's always particle based, and I try to trail those particles to get interesting details. It looks like the velocity is quite strong, as well as the temperature, I think. Set this to 10, 100. No. Yeah, the temperature is definitely very strong. There's a lot of temperature. So I'm not gonna do too much buoyancy. We can leave the temperature field if we wanted that, but it's not required for this example. And one last thing I want to add before this, I want to diffuse the nodes, the smoke. So we're gonna add gas diffuse. Sorry, not a gas diffuse. I want to dissipate the sim. So gas dissipate. Come on. And I'm going to use evaporation rate of 0.2. And let's copy that dop import and update it to match this. Okay, let's view it with lighting, and with the high resolution. No need for temperature, no need for this at the moment. Let's increase sensitivity by 10. Let's hit play. And the velocity is quite strong. See, this was getting these mushrooms. I don't want those shapes. I just want the spikes, and generally they don't generate too much plume like that. So the turbulence that I added was a way to break it up. But I think what I'm going to do is I'm going to increase these two. I'm going to set this to 20. I'm going to set this to 10. I'm gonna lower the initial velocity and only keep 20% of it, and this guy I'm gonna keep 20% as well. So this way we get more noise, more velocity that has noise in it versus the one that is straight, that is coming from the sim. Let's go back. Let's reset the cache. Okay. Let's hit play. Cool. I'm going to increase the resolution of this a bit more. Lower the velocity by, let's see, I'm going to lower the velocity 0.5. Lower the temperature a lot, maybe just 2 at the moment, and let's increase this to 8. And gas dissipate, gonna lower that, and let's lower this to 0.08. And I'm going to run the sim, and we'll check it out in the next video. Thank you guys for watching, and see you in a bit.